So unfortunately, Nick's audio wasn't working, so I'll be recording his part of the presentation as well. So we wanted to make data frame-based graphs within Databricks and Apache Spark. To do this, we loaded in the Graph Frames library. This simplifies interactive queries, supports motive finding for structural pattern searching, and it also helped us benefit from data frame optimizations. So this is just an explanation of the graphs with the flights and the airports. As you can see, we have the relationships between all of these. So we have the source, which is the source flights, the destination, which is where the flight will be ending up, the delay, which is the amount of time that the flight was delayed in minutes, and the trip ID. We also have a vertex here. That's the ID of the airport. So here JFK represents JFK Airport in New York, the city, and the state. So this is just an explanation of how graph frames works. We have the vertices, which is the data frame, one vertex per row, and the ID is the column with the unique ID. And then we have the edges data frame, which is one edge per row, and that includes the source airport and the destination airport, along with the delay and the trip ID. You'll note that one of the delays is a negative number. That just means the flight was early. So we have a little demo that we created, which is just building a graph frame. So we loaded the data in as a data frame, as you can see here. After that, we used this code in order to build the graphs. We were also able to do a few basic calculations. So as you can see, we calculated the max delay time, which was 1,642 minutes. That's a very long delay. We also, using this package, were able to display all of the airports and the connections here. So we have a lot of smaller airports as well as the larger ones. If you look at Illinois, we've got O'Hare and Midway. We've got a couple in Texas that are pretty big. In New York, we have the Atlanta, Georgia airport, which is absolutely huge. But then we also have a bunch of small airports throughout the country. There's a couple in South Dakota, Wyoming, Maine, just little airports that may have connections to larger ones. So the queries that we're using were simple queries, like SQL queries, as well as motif finding, and then we graphed some algorithms. So the simple queries, we just did regular SQL queries on the vertices and edges. So for example, which trips are most likely to have significant delays? So the vertex degrees, we did the number of edges for vertex, incoming, outgoing, and total. And for the triplets, we joined the vertices as edges to get together the source, the edge, and the destination. So we then created a little table with trip delays greater than 0. Here we created a table that displays the top 20 page ranks as per the flight delays. So as you can see, we have the ID of the airport, the city it's in, the state, the country, and then that page rank. From there, we created a map depicting the trip delays. So it's basically a heat map. The darker color represents more trip delays, and the lighter colors represent less. As you can see, a lot of the states with a lot of trip delays are very populated. So we have California, Texas, Florida, Illinois, and New York. Those are very dark. We also have one state that is dark that isn't necessarily as populated. That's Georgia. And this is because the Atlanta airport is a huge international hub and sees a lot of people going in and going out. So for that reason, it's going to be a little darker. We also created a map that's the graph that's the degree order in terms of location and delays. So as you can see, again, Atlanta is absolutely huge because it's a huge airport and it has a lot of people coming in and out. We also have DFW, which is Dallas-Fort Worth, ORD, which is O'Hare Airport, and LAX in Los Angeles, and going from there, all of the other popular airports. These are the top trips based on the destination and the source. So LAX in San Francisco was definitely the #1 trip with over 3,000. We also had LAX and LAS, LAX and JFK. All of these are extremely popular airports that have a lot of transfers and connections. This is the list of transfer airports by the degree ratio. So as you can see, Minneapolis is up there, Chicago's up there, Phoenix is up there, and San Francisco, which, as we'll find out, San Francisco has a lot of transfers to smaller airports like Jackson Hole, Oklahoma City, airports like that. From there, we created a data frame of the motifs, which can be seen here. It's definitely a lot more complicated, but we did that using the graph prime function. We also created a data frame for the filtered paths. This one just represents flying from San Francisco to Buffalo. And finally, we calculated the degree ratio. Just something to note, we did see a lot of delays in the trips from San Francisco to smaller airports, and that's going to be important as I interpret the analysis that we conducted later on in this presentation.